Well, welcome back. This is part 2 of my game programming series. Right now we're working on making this game. Last time we learned about character input from the keyboard. And today we are going to be learning about basic artificial intelligence, AIs. This is pretty much the most basic AI you're ever going to see. All it's going to do is try and align its path with the ball on the screen, and it's going to chase the ball. And if it hits the ball, it's going to blow up. That's pretty much how it's going to work. So now, how are we going to do this? Well, just like in that tutorial I showed you guys earlier about sprites, I told you guys how to use the timer command. Every yada yada milliseconds we go to yada yada branch label. I call it timer ticked, and then so we'll make that here, and I'm going to let's have it print out redraw the sprites here. So sprite XY, don't forget to tell it which one, ball, X, and Y. Redraw sprites. And so it's going to do that every 50 milliseconds, or you could change it if you think that's too fast. See, the problem is if you get it going too fast, then if it tries to execute too much code than it can in that amount of time, then it starts to bog down and become unresponsive. When we quit, we'll stop the timer, and do that by saying timer 0. And now I shall teach you how to use subroutines. Subroutines are often useful in game programming because if you have a certain thing that is used more than once in the program, you don't want to list it so many times. You just want to be able to run that piece of code and then go back to whatever it's doing. And so you do that with the word go sub. It's like go to, only it comes back to this point after it runs that piece of code. And then you have a branch label. And I'm going to have two subroutines. One that is called enemy move, and then I'll move the enemy. That'll be our AI engine there. And then we'll have one for testing to see if there's a collision between the two sprites. So we'll have a collision test. And actually, you know what? Something in the back of my mind tells me that goes after this. Now, if you're wondering what this is for, well, it's just to reset the value of character, because if say I click W, it'll stay W for the next time it goes through this, and it'll do that again. So if you hit W, it'll just keep on going upwards even if you let go of the button, unless you have a line like that. Alright, this is pretty much all we need for the timer ticked loop here. Let's work on the subroutines. So the first one is called enemy move. Moves or move. And I always add the word return right away, and that goes at the end of every subroutine. Returns it back to where it came from. And now what are we going to do? Well, if you remember, when I added these variables here, this is pretty much going to be the meat and potatoes of our AI. If you haven't had trig yet, don't stress out about this next part, just take it for granted, but I'm going to make a unit vector. So basically a unit vector is like kind of getting the direction of the where we want it to go, but without having the magnitude affected. So to do that, we'll do enemy dx equals, now we want it to be in the direction, what am I trying to say? Well, the change in distance, it's like a vector, enemy dx and enemy dy, you know, dx, dy, get this, and we'll have this equal to the x of the thing it's trying to chase minus the enemy's x divided by the square root of that x minus enemy x squared plus y minus enemy y squared, and then take the square root of that. So you basically divide it by the Pythagorean theorem, or the distance theorem, and that will normalize it. I mean, it'll what am I trying to say? Well, do the same thing for dy. Control C, Control V, y, y. That's all the same. Now, this isn't in the correct syntax. I'm just putting it in vector form, just to show you what's going on here. If you don't know what this is, don't freak out. I'm basically just making its direction line up with that of the ball it's trying to chase. Oh wait, I'm missing something. Everything's getting messed up here. Alright. This here, forgot to take the square root of it. So if you don't know what I did, look up unit vectors. Alright, now we do enemy x equals enemy x plus enemy dx. Enemy y equals enemy y plus enemy dy. Then, coming on up here, let's put it there. Sprite xy enemy x enemy y. Let's see, what else do we need to do? Well, I think that might just be it for the enemy move subroutine. Might just be all we need to do. So let's get started on the collision testing. And here's how that works. Basically, there's a command in Sprite programming called Sprite Collides. And which sprite are we interested in? Well, we're interested in the ball, because that's our main character. Wait, what am I doing? And then it'll put whatever sprite collides with that sprite into this variable, list. So, if list has not collided with anything, it's going to be that. It's going to equal Nothing. Zero, zilch, nada. But as soon as it collides with the enemy, we can say, I mean, we'll know because it'll equal this enemy. But just because we can, I'm going to do if list equals, doesn't equal zilch, then obviously it equals the enemy, and we'll do something. Here's what we're going to do. We're going to get rid of the sprite, the ball, and we're going to replace it with a sprite that's a big explosion thingamabobber. And we're also going to play a sound effect, a big boom sound effect. And let's see, what else are we going to do? That's basically it. So all you need to do for this, print number 1, remove sprite, what's it called, ball, print number 1, add sprite. Have I added it as a BMP yet? Yep, here it is. It's called EXP, and it's a big explosion. Add sprite EXP. EXP. Where do we want it? Well, we want it where the ship was, which is X and Y. So, but not exactly X and Y. How about X minus 20 or so, because it'll shift down and to the right a little bit if we just say X and Y. Alrighty. Then we'll just play a sound effect here. Play wave. I've already made it. Where is it now? It's in the folder media. What's it called? Whoops. exp.wave. exp.wave. And then just issue this command just because I've gotten into the habit of it. And let's stop the timer, because otherwise, you know what'll happen? It'll say, it'll continue to do all this stuff, and it'll say, well, I don't know what sprite ball is, because we removed it down here. So say timer 0. That's also why I moved these to this side of the sprite XY commands, because if you're on this side and it collided, then it's still going to run through this before the timer stops. I mean, once, even after the timer stops, is what I'm trying to say. And that's pretty much all you need for the collision testing. This was basically the new thing here. I think this might have been new as well. But, am I forgetting anything? Well, we'll see what happens. Maybe it'll yell at me. Yeah, there was a lurking error. What's the issue? And if expected. Don't be me. Now let's try it. Look what's chasing me! It's coming after me! Ah! Funny thing is, it's still going in the same direction even after I release it. What happens if I run into it? It was supposed to disappear and replace it with an explosion, but it didn't. Strange things are happening, and I thought I had this all figured out. Dup-de-dup-de-dup-dup-dup-dup. Aha! This is what I need to do for one thing. This thing I'm confused about though, because it should have added that explosion. So it's that bitmap. Alright, well that's fixed. Let's try running into it again. It plays a sound effect, so it's running through this. Sprite XY. Oh, it doesn't redraw sprites. raw sprites. That's what the issue is. Okay, now it should work just like a dream. Ah, it's chasing me. Ah. What do I do? Well, give in, I suppose. Ta-da! And if you think it's going too slow and it's not a challenge, you can multiply dx and dy by a number. And see, now it's much more of a challenge, because that piece of pizza, boy, it's coming after me. I don't know. Oh boy. Oh, you got me. Well, that's that. Actually, before I cut out, I was going to show you this other game I've been working on, kind of as my own project here. This one's a little bit more complicated, and it's only like 1/3 done, I'm guessing. But, ta-da! It's kind of a side scroller, see? And then you can pick up little packages of TNT, and these don't do anything yet. The fuel and the health don't do anything yet, but you can pick up packages of TNT and drop bombs and stuff. And then these ships will come and chase you and stuff using the same AI method that I just showed you. Ooh, look, I have a bomb. But there's nobody to drop it on yet. Well, there, I'll just drop it anyway. And as you can see, there's still a lot of work to be done because it didn't explode when it hit the ground. I was hoping an enemy would show up. Oh, there's one. As you can see, I'm going faster than him. Just come back and let's see him. Say hello. Yeah, it's not really fun to play yet, so I'm working on it. But watch this. Yeah, you can blow up. So, game programming, it's real fun. You have just taken your first step in becoming a masterful game programmer. And I'm thinking this series is not going to get any more complex than stuff like this. Side scrollers and 2D sprites and stuff. Especially because we're using Just Basic, and that's pretty much all Just Basic can do. I'm not going to get into any 3D graphics or animations or engines or anything. But if you're interested in that sort of thing, I recommend going to The New Boston and check out his awesome videos. He's working on a new series right now that you should really check into. It's awesome. Anyway, that's about it. See you next time.